All right, let's just take a look at this and see what we got here. So we're asked to prove that the triangles are similar. Excuse me. Here's the way my brain kind of works. If we're going to ask that to prove that the items are similar, we've had three methods that we know how to prove proofs are similar. To use side, 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 or side angle side, we have to have actual number lengths for the sides to compare the ratios. And since this proof specifically doesn't have them, that means that the only possible way I can prove is angle, angle. So then my goal is to use the given information that EB is parallel to CD to state that I've got two similar triangles. And I guess the other thing to really pay attention on is, well, what triangles are we trying to look at? Right? We got the little triangle up top, and then I've got the big triangle down below. And my goal is to prove that these two triangles, the yellow is similar to the green. Well, it doesn't matter which route you take. You could start with using the given information. And that's what I like to do is, what does this information tell me about potential angles that are congruent? So if I have two parallel lines and they're cut by a transversal, now I could pick this transversal or I could pick this transversal, but I've got angles that are in the same position. So angle D is congruent to AEB, and then we have to state, why do we know those angles are congruent? Now, as we mentioned, if I'm going to pick the yellow triangle first, it doesn't matter. You can go green to yellow or yellow to green. I'm going to go yellow to green. I can't say angle E because that doesn't tell me specifically what angle. So I have to be more specific and say angle AEB is congruent to, and you could say angle D here because we know what that is, or it's kind of better to just use the full ADC. That's the angle of the big green triangle. Well, why are those two congruent? That's the question. Well, it's based off of parallel lines. These are parallel lines and the angles are in the same position, which are corresponding angles. And we had a theorem back in Unit 2 or Unit 1 that said if corresponding angles, or if two parallel lines are cut, then corresponding angles are congruent. So that's why I know I have one pair of angles. Now, if you wanted to, you could use the same statement and say that angle ABE, this angle right here, is congruent to angle ACD for the exact same reason. And then you're basically done with your proof, right? Or the other option is right here. I'm going to do this in a different color so it stands out. Angle A. Now here I can say angle A is congruent to angle A. And the reason why is it's the same angle for the green triangle and the yellow triangle. And that's our reflexive property. So now I have two pairs of angles that are congruent. And by the angle-angle similarity theorem, then I can state that triangle AEB is similar to triangle ADC by angle-angle. Okay, so if you're going to log on to Configure, you want to close all other tabs. Nothing else should be open on your computer except for Configure. Go to the regular search bar and just type in www.configurit.com. And what students are doing is they're using the auto predict, and sometimes that brings you to the wrong site. And also notice that I'm on Google Chrome. Don't try to use a different web browser. Chrome is probably the most compatible. And then you're going to go to your student sign-in. And I think this is my sign-in count. It should be. Okay, it's not. But this is a teacher one. I assigned new proofs, and I want to show you a couple of things. You have my activities, you have all activities. All activities, if I click on that, that gives me all 460 proofs possible. We don't want that. We want to go to my activities, and then I want to look at the ones that have not been started yet. And now I already did some, so you should have, if you did everything already, you should have, I think it was 7 or 8, I think it was 7 similarity triangles. Now we're going to look at how do you do similarity using angle, angle, side, angle, side. You can see some of mine are done. I already did the side, angle, side 1, the side, angle, side, or the side, side, side 1, and side, side, side 2. So you have new ones that are similarity. Another way to view that is if you just click on triangles and similar triangles. Here we go. That's the best way to do it. If you click on triangles and similar triangles, you can view the ones and you can see the green dots have already completed. But you've got 7 that are assigned. Now, I'm going to show you one that you were not assigned yet. And hopefully you're not on Can Figure It yet. Do not try to jump ahead. Just watch this really quick. So I'm going to pick ones that was not assigned yet. And I believe, let me just double check so I don't do the wrong one. It was side, angle, side 4. You were not assigned this one, but I want to show you how it works. So side, angle, side, similarity 4. All right. Now, notice this one's a little bit different, so you won't have to do as much as I'm doing, but I want to show you one thing in particular. So they tell us what method we're going to use, side, angle, side. So I know I have to prove I have one pair of congruent angles, and then I have to prove that the 2 side lengths are proportional, and it gets really tricky here. So first thing I'm going to do is just say, you know what, I've got some angles. Both angle measures are the same. So I'm going to go to angles with equal measure. And then I'm just going to say, well, what are they? Well, AB or CBA is the same as DEF. Click confirm. And then how do I know that? Because they're of equal measure. It says that right here. They're both 70. Oops. And notice when I clicked on that, it did something weird. I have to just type in 70 there. You're going to have to type in a lot today. That's what makes this a little different. So when I hit submit, notice it didn't prove they're congruent. It just proved they're equal. So now I'm going to just prove that they're congruent. And why do I know that these 2 angles are congruent? Because angles with equal measures are congruent. They're both equal to 70. And since I proved that they're equal, then I can use the statement to say they're congruent. You won't have to do that today. Okay, that part you don't have to do. But the part you do have to do, notice this gave me a 1 pair of congruent angles. The part you're going to have to do is use the givens to set up a ratio of sides. So pay really special attention to what I'm doing right now. I want to go to side lengths, and I want to show that segments are proportional. See how it says AB equals CD? That's a ratio, equaling a ratio. So I'm going to click on that, and then you have to go small to small, and you have to go from what they tell you. So I'm going to start with the triangle CBA. So notice, AB is 40. That's the small side on this triangle. So if I click here, AB, and this isn't a subtraction, this is a divide bar. So AB over, I'm picking the small side of these 2, which is DE. So AB over DE has to equal the ratio of the large triangle or large side, which is BC, over the large side of this triangle. So I compared small to small, large to large, and notice every time I took something from this triangle, it was in what's going to be the numerator. Every time I picked something from this triangle, it was in the denominator. And that's based off of the way that this is written. So think of numerator, denominator. All right, so now that's my claim. But they're going to ask me, why do I know that? Well, it's always going to be pairs with the same ratios are proportional. And then I have to physically say, okay, well, what is the length of AB? So I'm going to type in 40. And then AB was the small one in this triangle compared to the small one in this triangle. So 40 over 120. And that's equal to BC is 55 over the longer length down here, which is 165. And they're telling me that it will basically calculate that for us. So now I just proved that these ratios are equal, side, side. And notice when I hover on it, this part lights up. So I have the angle, I have the sides. That's enough to do not angle, angle, not side, 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 but side, angle, side. If the angle of one triangle is congruent to the corresponding angle of another triangle, and the length of the sides, including these angles, are proportional, then the triangles are similar. So then I have to state my proportions, which notice I can't snap this in here anymore. You have to be very careful. You have to match this ratio exactly. So I'm going to start with AB. I'm going to start with AB over DE. And again, that's small side to small side. And then it was BC over EF. BC over EF. And then the angles, I had to prove they were congruent. So I'm going to take the congruent one, not the equal one. And that should be enough to prove my triangles are similar. Okay, I want to go back to one more. And I'm going to do one that I already did because we only have two sides, but I'm going to actually, you know what? I take that back. I'm going to go to side, one. All right, and I already did this one, so I'm just going to click restart. This is super tricky. All right, you have to pay really special attention here. First thing, notice how you have two triangles. It tells us which triangle should come first. So PQR, that's going to be the yellow triangle on the bottom. And I'm going to compare that to SPR, which is the purple triangle that highlighted up here. And then they give me just the lengths. Now notice, I've got all three side lengths, which means I can use side, side, side. All right. So what are we going to do? We have to create proportions. The problem or the challenge with this one is when I go to proportional segments, I can only compare a small side to a medium side. I don't have what's called an extended ratio. So I can't compare all three sides at once, which means I have to compare all of them together. So here's what I would recommend. Start with the triangle that they gave you and go with small side. So of the three triangles here, or sides, 8 is the small one. And then I'm going to go to the triangle up top, and I'm going to pick the small side of that triangle. So small side to small side. And then I'm going to compare medium side. Well, that's 16. And then I'm going to go to the triangle up top, and the medium side of this triangle up top is 20, or PR. So I compared small to small, medium to medium. All right, and then I'm going to click confirm. And we always are going to pick the ratios, the pairs are the same ratio. And then we have to plug in the numbers. So what was PQ? You have to physically type that in. 8 to PS, which was 10. So small side to small side. QR was 16. That's middle side to 20. That's the middle side on this one. And I'll hit submit. Now, that just gives me the small side to the medium side. I need to compare all three relationships. So I'm going to go back and do proportional segments. And this time, I'm going to compare the small side to the large side. So I'm going to go small to small. So small to small is the same. Then we're going to go large side. So that would be the large side of the bottom triangle is 20. and the large side of the top triangle is 25. So small to small, large to large, and then we're going to pick that same, ratios are the same, and then we have to plug in the numbers again. So it was 8 over 10, that's small side to small side. PR was the large side of 20 to the large side of 25. All right, so now notice I compared small to medium, small to large. The last thing I have to compare is medium to large. You want all of them to be compared. So then I'm going to go back to it, and I'm going to compare the medium side, so QR, to the medium side on the top triangle, which is 20. So that's medium to medium. And now I got to compare the large side of the bottom triangle, which is 20, to the large side of the top triangle, which is 25. So confirm, same thing. And then you have to plug in the numbers. So QR was 16, medium side to medium side on the top triangle, PR was 20. And then the large side for the bottom triangle is 20. And large side for the top triangle is 25. All right, and then hit submit. So when you look at this, for side, 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 you will have 3 different ratios. Small to small, medium to medium, small to small, big to big, and then medium to medium, big to big. And once you have all 3 of those ratios set up, then you can prove by side, side, side similarity that these ratios are all the same. So then you have to just finally follow them all in. So you're going to go small to small, medium to medium, and then large to large. And the important thing is see how they put PQR here? That was the first part. You want to make sure you're grabbing from the correct triangle based off of the similarity statement that was written. And then we're done.